Hello everyone, here is Khaled Omar, and in this video I am going to demonstrate Chapter 4 of the CCNA 200-301 Volume 1, which is using the command line interface or the CLI. The contents of this video will be two elements. The first one will be we will learn how to access the Cisco Catalyst Switch CLI. And the second part, we will learn how to configure the Cisco iOS software. So let's start by the first one, accessing the Cisco Catalyst Switch CLI. Let me bring the pen. First of all, Cisco uses the concept of a command line interface with its router products and most of its Catalyst LAN switch products. So what is the CLI or the command line interface? It is a text-based interface in which the network engineer enters a text command and presses enter. So pressing enter sends the command to the switch, which tells the device to do something. It is like giving a command or an order to the switch to do something. This will be accomplished by entering a text and pressing enter, and this will go to the switch as a command. The switch does what the command says, and in some cases, the switch replies with some messages stating the results of the command. So what this means? It means when the switch receives the command, it either do something or replies with some messages stating the results of the command. Cisco Catalyst switches also support other methods to do both monitor and configure a switch. Let's give an example. A switch can provide a web interface instead of the CLI so that an engineer can open a web browser to connect to a web server running in the switch. Switches also can be controlled and operated using network management software. And with your experience, you will face a lot of network management softwares that can control and operate the networking device, the switch or router. Let's start to discuss what are Cisco Catalyst switches. Within the Cisco Catalyst brand of LAN switches, Cisco produces a wide variety of switch series or families. Each switch series includes several specific models. So one series has some specific models of switches that have similar features, similar price versus performance trade-offs, and similar internal components. Let's give an example. The Cisco 2960-XR series of switches was a current switch model series. Cisco positions the 2960-XR series family of switches as full-featured and low-cost wiring closet switches for enterprises. What this means? It means that you would expect to use the 2960-XR switches as access switches in a typical campus LAN design. What is the meaning of access switches? Are switches that are used to connect to end devices. And end devices can be PCs, access points, printers, laptops with cables, and so on. And there are several or two different other types of switches that can be used in a typical campus LAN, like the aggregator or the distribution switches and the core switches. But for the purpose of this demonstration, we are going to discuss the access switches. The following figure 4-1 shows a photo of 10 different models. As we mentioned, the series has different models from the 2960-XR switch model series from Cisco. Each switch series includes several models with a mix of features. For example, some of the switches have 48 RJ45 unshielded twisted pair, 10, 100, 1000 ports. What this means? It means some switches has 48 ports, Ethernet ports, and some switches have 24 RJ45 UTP Ethernet ports, meaning that these ports can auto-negotiate the use of the 10 base T, 10 megabit per second, or the 100 base T, 100 megabit per second, or the 1000 base T, 1 gigabit per second Ethernet. This is the meaning of 10, 100, 1000 ports. It means that they can negotiate the speed before they are using before the traffic will flows in the ports. This is how the 2960-XR Catalyst switch series looks like. They come in 10 different models, each with some features, and they may vary a little bit from each others. Like, for example, here, this switch has 24 Ethernet ports, UTP ports, that works at 10, 100, and 1000 megabit per second. The other switch has 48 ports with 4 uplink ports. As we discussed before, the SFP ports that can be used for the purpose of connecting the access switches to the upper layer switches, like the distribution or the core switches. So these uplink ports uses SFP or SFP plus to provide the uplink connectivity to the upper layer. Cisco refers to a switch's physical connectors as either interfaces or ports with an interface type and interface number. The interface type, as used in commands on the switch, is either Ethernet, fast Ethernet, or gigabit Ethernet, and so on. 10 gigabit Ethernet, for example. For Ethernet interfaces that support running at multiple speeds, the permanent name for the interface refers to the fastest supported speed. What this means? The ports from the 2960-XR series switches has gigabit Ethernet ports, which is the fastest supported speed. And for example here, as we mentioned, the 10, 100, 1000 interface, that is an interface that runs at 10 megabit per second, or 100 megabit per second, or 1000 megabit per second, would be called Giga Ethernet, no matter what speed is currently in use. It can use 100 megabit per second, for example, but still has the name Gigabit Ethernet port because it can work to the fastest speed, which is 1000 megabit per second or 1 gigabit per second. To uniquely number each different interface, some Catalyst switches uses a two-digit interface number X/Y, while others have a three-digit number X/Y/Z. For instance, two 10, 100, 1000 ports on many older Cisco Catalyst switches would be called Gigabit Ethernet 0/0, for example, and Gigabit Ethernet 0/1, while on the newer 2960-XR series, two interfaces would be Gigabit Ethernet 1/0/1 and Gigabit Ethernet 1/0/2. Sometimes you are using switches in a stack, and for standalone, they will have the name Gigabit Ethernet 0/0 or X/Y. And on a stack, they can have another number, the switch number on the stack, and then the port number, and so on. But don't think about stacking right now, because it will be discussed or demonstrated in another videos, later videos, not in the CCNA. So now let's discuss accessing the Cisco iOS CLI. How to access the Cisco switch iOS command line interface. Like any other piece of computer hardware, Cisco switches need some kind of operating system software. So Cisco calls this OS the Inter-Network Operating System, or the iOS. Cisco iOS software for Catalyst switches implements and controls logic and functions performed by a Cisco switch. Cisco iOS also defines an interface for humans called CLI. So the iOS defines an interface for humans called CLI, or command line interface. This is what CLI stands for. Cisco iOS CLI allows the user or the network engineer to use a terminal emulation program, like PuTTY, for example, which accepts, or TeraTerm, which accepts text entered by the user or the network engineer. When the user presses enter, the terminal emulator sends that text to the switch. The switch then processes the text as if it is a command, does what the command says, and sends text back to the terminal emulator. So you can see the result of this command. The switch CLI, the Cisco switch command line interface, can be accessed through three popular methods. What are these methods and how to access the switch CLI? You can use the console port, or you can use Telnet, or Secure Shell, or SSH. Two of these methods, Telnet and SSH, use the IP network in which the switch resides to reach the switch. What this means? It means that you can use here a PC with a terminal emulator, and you can type the IP address of the switch, and through the TCP/IP network, you can access the switch command line interface. The console is a physical port built specifically to allow access to the CLI. Each switch, like for example the 2960 switch, has a console port, this port. And you can access the switch through this console physical port through a PC with a terminal emulator and a console cable. This console cable has some different forms, as we will discuss in this slide. The physical console connection, both old and new, uses three main components. The physical console port on the switch, like this one, and this one, and this one. A physical serial port or USB port on the PC, like this one, serial port, this USB port, and this USB port. And by the way, the console port here is for RJ45 console port, and here RJ45 console port, and here a USB console port. The third main component is a cable that works with the console and serial or the USB port. What this means? It means that if you have a switch with RJ45 console port and a PC with a serial port, you would use a rollover cable. This is how the rollover cable looks like. This RJ45 connector will be connected to the switch console port here, and this serial port or RS232 port will be connected to the PC serial port. But if you are using a laptop, for example, to connect to the switch CLI, you may have not a serial port. You may have a USB port. So what you will do in this case, you will use a USB to serial converter like this one. This will be connected to this serial port and convert it into a USB port, where the RJ45 connector will be connected to the switch console port, RJ45 console port, and this USB port will be connected to the PC or laptop USB port. The third type of cables is a USB cable. When you have the option of USB console port on the switch and the USB port on the PC or laptop. So this USB port will be connected to the PC or laptop, and this USB port will be connected to the USB console port. This is how the RJ45 console port looks like, and this is how the USB console port looks like. There is a note here: when using the USB options, you typically also need to install a software driver so that your PC's operating system knows that the device on the other end of the USB connection is the console of a Cisco device. When you will purchase this cable or this cable, you will have a software driver with it. So you have to install it in your operating system, like for example Windows 10, Windows 11, or Mac. So the driver will be installed and the OS will recognize that the device on the other end of the USB connection is a console of a Cisco device. Cabling of the console connection. After the PC is physically connected to the console port of the device, PC or laptop, and the device is switch or router, a terminal emulator software package must be installed and configured on the PC. You have to have a terminal emulator. The terminal emulator software treats all data as text. And let's give examples of the terminal emulator. We have PuTTY software. We have TeraTerm. we have secure CRT. Those are considered as a terminal emulator softwares that it treats all data as text and it accepts the text typed by the user or the network engineer and sends it over the console connection to the switch. Similarly, any bits coming into the PC over the console connection are displayed as text for the user to read. The emulator must be configured to use the PC's serial port to match the settings on the switch's console port settings. So you have to configure the emulator to use the same configuration as the switch's console port. And the default console port settings on a switch are as follows: 9600 bits per second, no hardware flow control, 8 bits ASCII, no parity bits, and 1 stop bit. Let's give an example here for POTI as a terminal emulator. We have here the speed 9600, the data bits are 0, the stop bits are 1. You have to configure this as a default configuration to be able to access the switch CLI, and parity none, and flow control X on X off. And to connect to the switch CLI through the console cable, you have to connect through the serial line, and it gives you a COM port that is on your PC or laptop, and you should know this port. By the way, we should configure this to match this port from your computer device manager. And how to access this device manager? You can, let's get out of here. Discard. Go to this PC. By the way, I am using Windows 11. And similarly in Windows 10 and other Windows operating systems, you go to Manage, Device Manager, and then because I don't use the cable at the moment, you will not find the ports or the COM ports like this one. When you have the cable connected, you will have this option, and when the driver is installed, you will be able to find that COM5 is the USB to COM port driver. So you have to configure this here as COM5 and then hit open, and you will be able to access the switch CLI through the console port. Let's discuss accessing the CLI with Telnet and Secure Shell or SSH. Terminal emulators, as we mentioned, PuTTY, TerraTerm, Secure CRT, support a variety of TCP/IP applications as well, including Telnet and SSH. Telnet and SSH both allow the user to connect to another device's CLI, but instead of connecting through a console cable to the console port, the traffic flows over the same IP network that the networking devices are helping to create. Telnet uses the concept of a Telnet client, the terminal application, and the Telnet server, the switch in this case. A Telnet client, the device that sits in front of the user. As a definition, accepts keyboard inputs and sends those commands to the Telnet server. The Telnet server accepts the text, interprets the text as a command, and replies back. Cisco Catalyst switches enable a Telnet server by default. So you don't have to enable Telnet as it is enabled by default, but switches need a few more configuration settings before you can successfully use Telnet to connect to a switch. And we will learn later what are the commands or the configuration settings that is required to be able to access the switch or the router through Telnet. Using Telnet in a lab today makes sense, but Telnet poses a significant security risk in production networks. Why? Because Telnet sends all data, including any username and password for logging to the switch, as clear text data. So if someone in your network will capture your data and you are using Telnet to access your switches or routers, these data will be in clear text and will be visible to anyone capturing the packets. So what should we do? We should use SSH in this case that gives a much better option. What is this option? SSH encrypts the contents of all messages. So it adds encryption. And this including the passwords, avoiding the possibility of someone capturing packets in the network and stealing the password to network devices. So now we learned how to access the switch CLI. What will happen or what we will see when we access the switch CLI? There are two modes for now, the user and enable modes. The enable mode sometimes is called privileged mode. So all three access methods, the console, Telnet, and SSH, places the user or the network engineer in an area of the CLI called user execution mode. This is the first mode that you will face when you access the switch, whether through console, Telnet, or SSH. The user execution mode, sometimes also called user mode only, allows the user to look around but not break anything. Just to look around. The execution mode part of the name refers to the fact that in this mode, when you enter a command, the switch executes the command and then display messages that describe the command's result. Cisco iOS supports a more powerful execution mode called enable mode, also known as privileged mode or privileged execution mode. The enable mode gets its name from the enable command, which moves the user from the user mode to the enable mode. So when first you access the switch through the console, Telnet, or SSH, you go to the user mode. And if you will type the enable command, you will move to the enable, sorry for the writing, the enable mode. If you will enter, this is enable to move to the enable mode. If you want to go back to the user mode, type disable. The other name for the enable mode is privileged mode. Refers to the fact that powerful or privileged commands can be executed there. For example, you can use the reload command in the enable mode, which tells the switch to reinitialize or reboot Cisco IOS only from enable mode. There is a note here. If the command prompt lists the host name followed by this sign less greater than, the user is in the user mode. If it is the host name, the switch name followed by the hashtag, the user is in the enable mode. Let's open Packet Tracer. And for example, Packet Tracer is a Cisco simulator that we can use to learn instead of labs. I am prepared it opened here. Let's have a switch 2960, and we want to access this switch through the console port. Let's have a PC here. And the console port here is RJ45 port. And the connection here is a serial port. So we have to use a rollover cable. And from here you can have the rollover cable connected to the RS232, which is the serial port, and connected to the console RJ45 port. Then through a terminal emulator, you should use the default settings as like this and hit enter, and then you access the switch through the console port. If you will hit enter, you will find that switch and the greater than sign. This means that you are in the user mode. To move to the enable mode, you have to type enable and hit enter. Then you will have the switch, this host name or the switch plus this hashtag. It means that you are in the enable mode. To go back, disable, then you will back to the user mode. Enable the enable mode. And through the enable mode, you can execute some commands, for example, like reload to reinitialize the iOS or reboot the iOS of the Cisco device. Let's hit enter. Proceed with reload, confirm, press enter. It is reloading right now. Remember that we issued the command reload at the enable mode, not the user mode. Because if in the user mode you will hit reload, you will type reload, you see it translating, nothing works in this mode with the reload command. Let's go back to the slides. As we mentioned, to move from the user mode, first of all, to access the switch, you have three options: the console port, Telnet or SSH. Once you access the switch, you will go to the user mode. If you will type enable command, like we typed enabled only, you will move to the enable mode. If you will type disable in the enable mode, you will go back to the user mode. And what differentiates between the user mode and enable mode? The sign near the host name. If it is greater than, then you are at the user mode. If it is hashtag, then you are in the enable mode. This is an example, as we mentioned earlier. that demonstrates the differences between the user and enable mode. Here, issuing the reload command in the user mode will not work. But if you will type enable, you will move to the enable mode. And in the enable mode, you can type reload and hit Y or enter to reload the device. So each mode has some of the commands that is acceptable only for this mode. There is a note here. The commands that can be used in either user execution mode or enable execution mode are called execution or exec commands. This switch has been pre-configured with a hostname cert skills. So the command prompt on the left shows that hostname on each line, as here. Cert skills is the hostname. If we want to configure enable, we can't configure the host name from the enable mode. So we have to go to the next mode or the global configuration mode or the configuration mode. This is something we are going to discuss in the next slides, but let's give it here. Type configure terminal, hit enter. You will move to the configuration mode. Type host name and give it a name, cert skills 1, hit enter. The name will be changed to cert skills 1. Let's go back to the slides. Here we are going to discuss the configuration mode, the third mode of operation of the Cisco CLI. And in this mode, you can configure the switch with configuration commands. For example, you can configure a name for the switch, which is called host name, using the following configuration command. First of all, you hit enable, type enable to move from the user mode to the enable mode. Then type configure terminal to move from the enable mode to the configuration mode. Then type host name space and the name. The switch name will be changed. And if you will type you can go back with exit command, type conf t, which means configure terminal, or you can type conf and hit tab. It will continue the word. Type ter and press tab. It will give you configure terminal and hit enter. Host name Khaled switch. And you can see here Khaled switch became the switch name. Let's bring the pen. Now we are going to discuss the password security for the CLI access from the console. Because as you saw, when we accessed the switch via the console, as we did in Packet Tracer, the Cisco simulator, we accessed the switch immediately without any password. So what this means? It means anyone who is physically near the switch can access the switch through the console port without any password, which is none from a security point of view. But as we said, by default, a switch allows console access only. And also by default, the console requires no password at all, and no password to reach the enable mode. The reason is that if you have access to the physical console port of the switch, you already have pretty much complete control over the switch. And here we are going to give an example how to configure password for the console port. And how to give a password for the enable mode. So let's go back to Packet Tracer. We are on the switch right at the moment. We will configure the password for the switch from the global configuration mode, as we are already here. To configure enable password, so when you are going to move from the user mode to the enable mode, you will be asked for a password. Type enable secret and give it a password. Let's give love. Hit enter. Now we configured a password for the enable mode. Then let's configure a password for the console port. To access the console port, type line console 0. Hit enter. Type login. Hit enter. Logging disabled on line 0 until password is set. So you have first to set a password. Type password and give a password like face. Face is the password. Hit enter. Type login, which means that you will use this password when you log into the switch through the console port. Hit enter. Let's go back, exit, exit, hit enter and exit. Now we back to the user mode and we are accessing the switch through the console port, so you will be asked for a password. Type faith, hit enter. Now you are in the user mode. Type enable to access the enable mode. You will be asked for a password, which we entered love. I am typing love right now. Hit enter. Now you access the switch enable mode. In this slide, in this example, as we mentioned, we give a switch host name, cert skills 1, and enable secret love, and we access the line console 0 and type to the password face and entered login. Login means that you are going to be asked for a password when you access the switch through the console port. So here we are giving more details about the commands. The enable secret love configuration command defines the password that all users must use to reach enable mode. Whether users connect from the console, Telnet or SSH, it doesn't matter. They would use the password love when prompted for a password after typing the enable execution command or enable exec command. The line console 0 is the command that identifies the console. The login command tells iOS to use simple password at the console. Finally, the password face command defines the password for the console. User must type when prompted. You can change this face to any value you want. So this is the password of the console port. Let's discuss here the CLI help features. As you know, no one should memorize all the commands because there are a lot of commands that can be configured on the switch or the router. whether in the enable mode commands or configuration mode commands. You can use the CLI help feature to remember the available command that you should type. You should use the question mark, which provides help for all commands available in this mode. You can type the command and hit question mark, any command here. With a space between the command and the question mark, the switch lists text to describe all the first parameter options for the command. And then here you type the part of the command and hit question mark. This lists commands that start with com. Actually, let's go to the packet tracer to show you how the CLI help features work. Let's go to packet tracer. We are now in the enable mode. Let's go to the configuration mode, conft or configure terminal. Type host and question mark. It will tell you that there is host name available, so you can type host name. You can type host and press tab. You can find the full name that you are going to use for this command. You can hit question mark. It will list all the available commands at this mode, in the configuration mode. Let's hit exit to go back to the enable mode. Hit question mark. You see all the available commands that can be configured on this mode, and they are different because here in the enable commands, enable mode, and here we were at the configuration mode, so they are different. Let's go back to our slides. And here you can type the command and the parameter and hit tab. It will, by hitting the tab key, it causes the iOS to spell out the rest of the word. Cisco iOS stores the commands that you enter in a history buffer, storing 10 commands by default. The CLI allows you to move backward and forward in the historical list of commands and then edit the command before reissuing it. Let's go back to packet tracer. And let's hit the up of the keyboard. You will find that we entered conft, and then press another up key in the keyboard. You will find that we entered the enable, then nothing all. So it is stored 2 commands, and by default it can store up to 10 commands by default. If you will use the down arrow, you will go back to this command conft and then nothing. Let's go to the configuration mode, hit up arrow, we hit end exit, and nothing more. So as we saw in packet tracer, the up arrow or control B, this displays the most recently used command. If you press it again, the next most recent command appears until the history buffer is exhausted. The down arrow or control N does the opposite. If you have gone too far back into the history buffer, these keys take you forward to the more recently entered commands. And the N key in the keyboard stands for next. B stands for previous. And the left arrow or control B, this moves the cursor backward in the currently displayed command without deleting characters. Let's try this. Let's type exit and the left key. You see, you can move without erasing the letters, left and right. So you can come here and type TTTT in the middle, or if you are missing an I letter, you can enter it here. So you can modify the commands as you want. And you can use backspace. This moves the cursor backward in the currently displayed command, deleting characters. So backspace deletes the characters. Now let's discuss the show and debug commands. These two commands are the most popular Cisco IOS commands is the show command, and also debug is also famous command or popular. But the most popular one is show. You will use it every day if you are doing your work or you are in a lab. The show command has a large variety of options, and with those options you can find the status of almost every feature of Cisco IOS. The only work the switch does in reaction to show commands is to find the current status and list the information in messages sent to the user. The debug command also tells the user details about the operation of the switch. So what is the difference between the show command and the debug command? The show command lists status information at one instant of time, more like a photograph at one instant of time. The debug command acts more like a video camera feed or streaming. You can have a live information comes every moment to you. So let's learn how to configure Cisco iOS software. And I think we mentioned some parts in the packet tracer example. If you are at the user mode and you want to move to the enable mode, type enable. Then you will move from the user mode to the enable mode. If you will type configure terminal, you will move from the enable mode to the configuration mode. If you are at the configuration mode and you want to go back to the enable mode, type exit or end or Control Z. This will move you back from the configuration mode to the enable mode. If you are at the enable mode and you type disable, you will move from the enable mode to the user mode. There are common switch configuration modes. And remember, they are configuration modes. The first one is the global mode, where you configure terminal at the enable mode and you move to the configure in between brackets and hashtag. And this mode, first mode after configure terminal. If you will type line and then, for example, line console 0 to access the console port and configure it, or you can type line VTY from 0 to 15, which is to configure SSH or Telnet. You will move to the line mode. If you type interface and give it a type or number and the number, you will move to the interface mode. It shows like that. If you type VLAN and give it a number, you will move to the configuration the VLAN configuration mode. Let's go to packet tracer and try these four modes. Let's hit exit. To go to the configuration mode, type configure terminal, hit enter. Then to go to the line mode, type line console 0, then exit, type line VTY from 0 to 15, then you will enter the virtual terminal mode or the line mode as well. Type exit, and then you can go to the interface mode. Let's give fast Ethernet 0/0. There is no 0/0, 0/1. And then you will go to the interface mode. Here we were at the line mode. When we entered line VTY 0 to 15 or line console 0, we moved to the line mode, configuration mode. And in the interface, and we give you the interface name and type and number, you will move to the interface configuration mode. Exit. You can type VLAN and give it a number 10. You will move to the VLAN configuration mode. This is some examples for you to learn how to move between modes. You can type here interface fast Ethernet 0/1, but this will not work. Type exit and type interface fast Ethernet 0/1, then you will move to the fast Ethernet. Type VLAN 10, you will move to the VLAN 10. So you don't have to be on the global configuration mode to go from one mode to another. Let's go back to our slides. As we mentioned, there is a note here. You can move directly from one configuration sub-mode to another without using the exit command to move back to global configuration mode. Here are some examples. As we mentioned, to move from the enable mode to the global configuration mode, type configure terminal. To go back, hit end or control Z or type exit. To go to the interface mode, type interface and number, hit exit to go back. And as we mentioned in the packet tracer, this gives you a brief description about this slide. So let's start to discuss the memory of the switch or the router. So how the switch stores the configuration. When you configure a switch or a router, it needs to use the configuration. It also needs to retain the configuration in case the switch loses power. Cisco switches contain random access memory or RAM to store data, while Cisco IOS is using it. But as all of you knows, RAM loses its contents when the switch loses power or is reloaded. So, to store information that must be retained when the switch loses power or reloaded, Cisco switches uses several types of more permanent memory, such as the non-volatile RAM or NVRAM. The following list details the four main types of memory found in Cisco switches, as well as the most common use of each type. The first one will be the random access memory, sometimes called dynamic RAM for dynamic random access memory, and it is used by the switch for working storage. The running or the active configuration file is stored here. The second type of memory is the NVRAM or non-volatile RAM. It stores the initial or startup configuration file. that is used when the switch is first powered on and when the switch is reloaded. The third type of memory is the flash memory. It is either a chip inside the switch or a removable memory card. Flash memory stores fully functional Cisco IOS images and is the default location where the switch gets its Cisco IOS at boot time. So flash memory stores fully functional Cisco IOS images, and it is the default location where the switch gets its Cisco IOS at boot time. Flash memory also can be used to store any other files, including backup copies of configuration files. The read-only memory, or ROM, stores a bootstrap or boot helper program that is loaded when the switch first powers on. This bootstrap program then finds the full Cisco IOS image and manages the process of loading Cisco IOS into RAM, at which point Cisco IOS takes over operation of the switch. So to summarize the function and the type of RAMs, the switch or router has RAM, flash memory, ROM, and NVRAM, these four types of memory. The RAM for the working memory and running configuration. NVRAM for startup configuration. Flash for Cisco IOS software, storing Cisco IOS software, and the ROM for the bootstrap program. Cisco IOS stores the collection of configuration commands in a configuration file. In fact, switches uses multiple configuration files. One file for the initial configuration, used when powering on the device, and another configuration file for the active or currently used running configuration as stored in RAM. So there are two types of configuration files. The first one is a startup configuration file. The second one is the running configuration file. The startup configuration file stores the initial configuration used anytime the switch reloads Cisco IOS. It is stored in NVRAM. The running configuration file stores the currently used configuration commands. This file changes dynamically when someone enters commands in configuration mode, and it is stored in the RAM memory. Essentially, when you use the switch configuration mode, you can change only the running configuration file or the running config file. This means that the configuration commands updates only the running configuration file. However, if the switch lost power right after the used configuration commands, all the configuration would be lost because they are stored in RAM, and RAM don't keep its contents in case of power loss or reload. If you want to keep that configuration, you have to copy the running config file into NVRAM, overwriting the old startup config file. To store the running config file into NVRAM and override the old startup config file, use the following command. And let's type here enable command, as we see here, switch plus hashtag. Copy running config, copy space running config, space startup config, or simply type right. Let's give an example here on packet tracer. Now we are on a switch and we typed a host name. Let's say exit Khaled dash switch for this switch. Let's do reload. It will ask you, do you want to save the configuration? Hit no, enter, proceed, hit enter. As we may expect, nothing of the configuration will remain because as you can see, it backs to the default, and we lost all the configuration because we didn't copy the running config file into the startup config file from the RAM to the NVRAM. Let's go to the enable mode. Go to configure terminal, give a host name, Khaled dash switch, hit enter, go back, type copy, running config space startup config, hit enter, destination file name startup config, hit enter, do reload, confirm. The data will not be lost, the configuration will not be lost because we moved it from the RAM to the ROM to the NVRAM. Let's see, you see Khaled the switch still exists because we copied the running configuration into the startup configuration. We can simply go to the enable mode, type write, and then we save the configuration from the running config file into the startup config file, or from the RAM into the NVRAM. Let's go back to our slides. Sometimes you may want to just get rid of all existing configuration and start over with a clean configuration. To do that, you can erase the startup config file using 3 different commands. Enable commands: write erase, write space erase, or erase space startup config, or erase space nvram : once the startup config file is erased, you can reload or power off or on the switch, power off on the switch, and it will boot with the new empty startup configuration. Actually, as a note, Cisco IOS does not have a command that erases the contents of the running configuration file. So let's do that in Packet Tracer to erase the configuration and bring the switch back to the default configuration. Let's go to Packet Tracer, type erase or write erase, hit enter. Erasing the NVRAM file system will remove all configuration files. Continue, press enter. Now we erased all the NVRAM contents. Do reload, hit enter. And now, as you can see, it back to the switch name, host name. So all the configuration we did are erased or removed. So to this, we come to end of this video. I hope it's been informative, and thanks for watching.